Good day to my fellow researchers. My name is Nurvin Ratha, and I, on behalf of my other co-authors, would like to present my paper. The title of my paper is Developmental Research on Sustainable Technologies to Minimize Problematic Road Embankment Settlements. As mentioned in the title of my paper, challenging problematic and non-uniform ground conditions is a very prevalent condition in Malaysia, and it is a very big challenge for geotechnical engineers, especially when construction of pavement and bridge embankment is done in soft ground, which includes clay and peat soil. Primary, secondary, and even the less known tertiary consolidation has to be considered into the design of construction. So what eventually occurs is, because of the soft soil condition, we have bumpy and uneven work surfaces, which is also very hazardous. We do have existing methods such as pile, vertical drain, soil replacement, and soil stabilization, but then at very soft ground, these methods have not been proven to be very effective. And despite using these conditions, still the road becomes uneven, which leads to a higher repetitive maintenance cost. So since there is no one fixed solution for all of this, idea of developing a lightweight sustainable technology has appeared. So the concept that we will explore in this paper is the masonry arch bridge structure, which I will later talk more about it. Going straight to the paper itself, for soft ground in Malaysia is an unavoidable situation. If we look at one of the figures which I've provided in the paper, all the soil conditions along the coastal areas are actually made of soft soil. And if we see the longest highway in Malaysia, the North-South Highway, is also actually built on certain parts of this soft ground. So in Malaysia, it is an unavoidable situation where geotechnical engineers do have to consider building roads and bridges on soft ground. Under the 11th Malaysian Plan, which will last from 2016 to 2020, the government actually plans to spend about 1.4 billion ringgit to upgrade 700 kilometers of rural roads nationwide. Whereas about 200 million ringgit has been given to upgrade Felga lands, and Felga lands is primarily lands which are dedicated for agricultural purpose, which is clay and peat soil, basically soft ground. So developing these areas will eventually bring about these challenges of settlement of soft soil. Thus, it is very significant to explore new and innovative concepts with a sustainable approach in developing long-term solutions in tackling problematic soft soil. New ideas are very crucial because this is how we solve existing problems. Even one example is uh, logs. Tree logs have been used as far back as 2500 BC in Babylon to uh, to tackle yielding soft ground to form a permeable, stiff but disconnected neck structure. To highlight more on the problem, one very interesting research by some personnel from the Public Work Department, JKR in Malaysia, in 2015, they have published a paper which mentions that out of 252 forensic cases, 182 cases are actually related to issue of ground settlement. So thus, this shows that a very high percentage, about 72% of the cases are actually due to ground settlement. One very good example will be a bridge embankment which is very close to the place where we are working, University Tun Hussein on, a bridge embankment near Parit Yangi. So over the past 2 years, the current research team has been monitoring this bridge embankment, and it has been found out that every 5-6 months, uh, settlement occurs along the embankment, and because of the settlement, it causes a huge discomfort to road users, and of course GKR has to come in and continue to do the maintenance and repair work. So for the past 2 years, at least about 5 times, the repair work has been done. And isn't this an additional cost to what unnecessary cost that we have to use the government's money to pay for? The reason why the settlement occurs, especially in an embankment, is because the existing ground is actually marine clay, which is actually very soft soil. So the high embankment consists of good backfill soil, but then this good backfill soil, the subsoil, is heavy, much denser compared to the existing soft ground conditions. So the gate load, which forms the embankment, over time pushes on the soft ground and causes deformation to occur. The problem is not so much on the dynamic load, because the dynamic load is a very temporary load which passes over a split second when the vehicle moves. But then the gate load, which is the subsoil above the soft subgrade, over time causes a much more deformation. Now I would like to highlight some of the innovative approaches in highway construction materials. There are many researchers which have been very innovative in solving these highway construction problems, especially the research on lightweight materials have been quite advancing in the recent years. Table 2 in my paper highlights some of these innovative materials. For example, recycled asphalt pavement, where the existing asphalt, because it is no longer uh, effective, so it is recycled and used back. But however, the recycled asphalt pavement is still heavy when used in soft ground condition. Other materials such as expanded polystyrene, or also known as geofoam, have been popularly adopted. However, this material, even though it's very light and effective, but then in places where the water table is high, EPS starts to float. Waste tires have been used in certain countries such as Canada, but waste tires are also heavy. So in UTHM currently, we are actually compiling all this information, and we are trying to take the good points out of all this existing material and to develop a lightweight, sustainable, economic rigid mat structure. Talking about environmental and sustainability, one of the very huge waste product is actually plastic bottles. In Malaysia, about 2 million tons of resin are produced annually, and about 40% is actually used in the packaging industry. So plastic bottles are basically also known as polyethylene terephthalate, or also known as PET. So plastic mineral bottles, which is made of PET, are actually a very big waste product. In an online environmental page, it mentions that 100 million plastic bottles are used up in the world every day, and only 1 out of 5 bottles end up being recycled. So actually 80% of the plastic bottles end up going to landfill and not being recycled and becoming a waste product. So one of a very promising material is actually plastic bottles. Talking about the masonry arch concept, is basically the masonry bridge is a very good design, because most of the masonry bridges in UK have actually exceeded the design life of 120 years. So these bridges work by transferring the weight of the bridge and its loads as vertical abutment, support reactions, and also partially into a horizontal thrust restrained by the abutments at either side. So if we see the masonry arch bridge, the whole bridge actually has a void in between of it. So even though having a void, but then the whole bridge is able to sustain a large load. So that is the concept that we are in UTHM are trying to explore, like how by using the masonry art but using lightweight fill material, we can basically reduce the amount of material used, the construction time, and also at the same time we do not make the structure too heavy that the existing subgrade soft soil cannot withstand the excessive load. So this whole paper, so the upcoming papers, the following up research from this will be to follow up on how we can use this masonry arch bridge concept and integrate with lightweight materials to form a sustainable method to minimize settlements in embankments. Thank you. So that's it from us. Thank you.